Hi everybody. Today's lesson is 2.4, solving equations with variables on both sides, and these are the objectives you're going to learn today. So we are going to use the rules for solving equations. The rules I had given to you yesterday in yesterday's lessons, 2-1 through 2-3. So let's look at this equation. In this equation, there are how many terms? There are 4 terms. You have the half x, there's a plus, and this one is 1/3 times x minus 6. So this entire thing is your second term. 5/6 x is your third term, and then we have a plus 2 as the constant. So you need to remove fractions, decimals, and parentheses. So the first thing we're going to do is distribute the 1/3. And so it will look like so. The 1/3 x and the 6 times 1/3 will become 2. Now I want you to take each term. Now we have 3 terms on the left and 2 terms on the right. Now you're going to take each term and put parentheses around each one like so. And each term you are going to multiply by the LCD of the fractions, and in this case the LCD happens to be 6. So we're going to put 6 on the left side, and we're going to simplify each term. So you should end up with 3 terms on the left and 3 terms on the right, and it will become 3x plus 2x minus 12 equals 5x plus 12. The next step is to combine the like terms on the left and the right, and you end up with 5x minus 12 equals 5. This should be an x minus 12. And so we can see that negative 12 becomes equal to 12. Remember, you have to remove the variable first. When you do this, you come up with a statement that is not true. So we can say that this equation really makes no sense, and this equation has no solution. So sometimes you can end up with an equation that has no answer. So the next step is to figure out whether your equation has a solution or not. So equations have 3 options. There can be no solution, exactly one solution, or infinitely many solutions. If your equation has exactly one solution, you solved it, you got an answer, you can say, you can write that answer in a solution set just like this. However, sometimes when your equation has no solution, like the one we did before, we use the symbol which symbolizes that there are no answers to this problem, no solution. And sometimes when we find that an equation has infinitely many solutions, that means every variable works, every real number solution works, we can say that that equation is an identity. So I'm going to show you how to do the work so you can get full credit for this type of question. So let's say we have an equation. I want you to solve it on your own and then see if you get the same work that I have. So we're going to distribute, and then we're going to combine like terms on either side, and then we're going to take care of the variable. That means we're going to subtract 2a from both sides, and that will give us negative 8 is equal to 4. And that is incorrect because negative 8 is not equal to 4. It is false. Therefore, this equation has no solution, and this is what you write in the very end. This does not get put into a solution set. This simply means there is no answer. However, if we have an equation like so, solve it and then check with me. So we first do distribution, then we take care of the variable. So you add 6x to both sides, and it turns out that 3 is equal to 3 is a true statement. Therefore, every number that we plug in for x will make the left side equal to the right side, and we say that this equation is an identity. And here's something new we are going to do today. What happens when we use reciprocals? Now, I'm just going to close this for a second. And let's say we have 8/7 x is equal to 80. Now, in order to remove the 8/7, we're going to multiply both sides by the reciprocal. Let me see this. Here we go. By the reciprocal of 8/7. So what you're going to do is first identify the terms. Hi. And you're going to put parentheses and multiply both sides by the reciprocal. In this case, it's 7/8 and 7/8. I want you to put the reciprocal on the left side of the term. And so the left, when we do the multiplication, it becomes x is equal to 70. And we write that answer in a solution set. But what happens when it looks different, like so? Here we have 8/7 times x minus 4. I know many of you are tempted to do distribution, but I don't want you to do any distribution. I want you to look at the left side. The left side here has two factors, 8/7 and times x minus 4. So we have two factors, and just like in the first equation, to remove the 8/7, we need to multiply by 7/8. You are going to rewrite. You're going to put parentheses around each factor, and you're going to multiply both sides by 7/8. You need to remember that this whole thing is one term. It's just written in a different way, but it is one term. And therefore, the left side, the reciprocals will become 1, and you'll get x minus 4 equals, the right side will be 133. And you solve and you put the answer in a solution set. So I want you to try the next one by yourself. Remember, on this side, on the left side, there are only two terms. Sorry, that was a mistake. Let me just clear that. On the left side, there is only one term, and in order to remove the half, do not distribute, but multiply by the reciprocal. And you are going to rewrite the equation. You're going to put parentheses around the half and the x. You're going to multiply this by 2/1 and by 2/1. The left side will now become 6 minus x equals 2x. The lower variable is the minus x, so add x to both sides, and then x is equal to 2, which you're going to rewrite properly, and then your solution set is 2. We're going to stop here, and we're going to do many, many interesting problems in class tomorrow. I'll see you tomorrow. Bye.